Welcome everybody to Algebra 1, Section 5.2, Linear Equations, Slope-Intercept Form, and Graphing. So linear equations are often, frequently, and I would even say most often, written in slope-intercept form, which is y equals mx plus b. Here, m represents the slope, b represents the y-intercept, and x and y just stay x and y. So this just stays x and this just stays y. Just like we have equations that are y equals some number plus another number. And so what we're going to do is we're going to take a slope and a y-intercept that we're given and just plug these in for m and b. Leave y and x as y and x. So for example, on number 1, if the slope is 2, that means m is 2. If the y-intercept is -1, that means b is -1. So this would be y equals 2 times x minus 1 or plus a -1. That would really be the same thing. And that would follow this form, y equals mx plus b. And as we continue to do this, we'll just keep plugging in the slope where the m goes, which is multiplying with the x, and we'll plug in the y-intercept where the b goes, which is adding or subtracting with the x depending on whether it's positive or negative. So number 2 would be y equals -3/5 x plus 4. 3 is y equals -3x plus 2. 4 is y equals -1x, or just -x plus 7. And 5 is y equals 1/4 x. You could put the plus 0, however adding 0 is just the same thing as 1/4 x. And number 6 here would be y equals -5/2x minus 3 or plus a -3. And reminder that where the negative is on a fraction doesn't even matter a little bit. The negative can be on the top, it could be on the bottom, or it could be out in front. Now we're going to go from a graph to identify the slope and y-intercept, and then from there make the equation. So on 7, we learned last lesson that to find the slope of a graph, we have to do the rise or run between points, and so the rise is 3, the run is 1. It is going uphill, so it would be a positive slope, and so the slope is 3/1, or just 3. The b is where it crosses the y-axis. In this case, -4 is where it crosses the y-axis, the y-intercept. The b is just the y value of that. And so our equation would then be y equals 3x minus 4. Number 8 here, we know it's going downhill, so the slope is going to be negative from left to right. It's downhill. And so we go down 6/4 between those 2 points, which reduces to -3/2. And the b, or where it crosses the y-axis, is 7. And that would be y equals -3/2 x plus 7. Next up, we'll have number 9 on the next page. We're going to once again identify the slope and y-intercept. You'll notice here, though, it doesn't give a spot to write the m and the b. So we're just going to have to find a spot to write it off to the side. Not necessarily required to find the m and b on this one as far as required to write it down. However, you would be required to find it as far as needing to know the information to write your equation. So while you aren't graded on whether or not you write an m or a b on a problem like this, if it doesn't ask for it, you would still need to know the information. So our slope is 2/5 for rise over run, and the b is 3. And it is a positive slope, by the way, because it's going uphill from left to right. And so this is y equals 2/5x plus 3. Number 10 here, the slope, or m, is 1. It ends up increasing by, I believe, 5/5, which just reduces to 1. The b is -6. And so we get y equals 1x, or x, plus a -6, or -6. Number 11 here, the slope is -2/8, which reduces to -1/4. And the b is 5. And so this ends up being y equals -1/4 x plus 5. Number 12 here, The slope between these 2 points is positive 4/3 because it's going uphill, so it's positive. And the b is 0 across the y-intercept at the y value of 0, across the y-axis at the y value of 0, excuse me. And so this is y equals 4/3 x. You could put plus 0 if you really want to, but I'm not going to. Number 13 here, our slope, instead of just simplifying to -2 or -2/1. And our b is -3. And so this gives us y equals -2x minus 3. If you wrote -2/1x, that'd be perfectly fine as well, because any number can be written over 1. Next up on number 14, the slope of this line is -5/6. It's going down from left to right, just like the line on 13 was. And the b here is 1. And so this says y equals -5/6x plus 1. On to number 15, we notice that the slope here is 1/3, or it's increasing by 2 for the rise and 6 on the run, which is 1/3. And the b is -2. And so this is y equals 1/3 x minus 2. Last for this page, number 16, I notice my slope is really -5/1, or it's dropping by 10 and running 2. But you just call it -5 like I am here. The b is where it crosses the y-axis, which is 8. And so this is y equals -5x plus 8. On to our next page here. Now we're going to graph equations when we're given slope-intercept form, or using slope-intercept form. So the first step is to write your equation in slope-intercept form, which we will not have to do on this page, but we'll have to do on the next page. Then we're going to graph the y-intercept, aka the b. I always like to say that you begin with b, being a little cheesy there. And the point is always 0, b, or 0, whatever the y value is, was your y-intercept, across the y-axis. Then we use the slope to create more points, remembering that slope is rise over run, and to note that the positive slopes make the line go uphill from left to right, whereas negative slopes make the line go downhill from left to right. And you can use a ruler to draw a line that extends to the points. Really, any straight edge works, or if you just draw them and connect the points, I'm happy with that. But the arrow does need to be on both ends. So here, we need to identify the m and the b. Since it is in y equals mx plus b form, we can know it's in y equals mx plus b form, or slope-intercept form, since y is completely by itself on that side, on one side of the equal sign. And so the m here is whatever's multiplying with the x, and this is -1 or -1/1 to put it in rise over run form. And the b is 5, so we're going to begin at b, remembering that it's a y-intercept, so it always is on the y-axis, so it's either going up or down, but not left or right, and the positive will go up. Noting that this graph is 6 by 6, it goes 6 up, 6 down, 6 right, 6 left from the origin. And so now our slope will be negative, so it's downhill. And so I either go down one, right one, or I go up one, left one. Remembering that where the negative on that fraction is doesn't even matter a little bit. So I don't want to get caught thinking, oh, the 1 is negative on the top, so that means I go down 1, but I can't go up 1 because the 1 is negative on the top. That's not what that means. It just means that you either go down and right because it'd be a negative to go down, but a positive to go right, or you go up and left because it'd be a positive to go up, but a negative to go left. Then we connect these, and you really only need 2 points to make a line, but I like to do at least 1 in each direction typically, as long as they fit on the graph. Now you could continue to make more points if you really wanted to, such as this, but the arrows get the point across, or get the idea across, that it goes on forever. Number 2 here, this is in slope-intercept form. It's y equals mx plus b. The slope is -3 or -3/1. I always like to put my slopes in as fractions when I'm writing these, or when I'm graphing these equations. My b is -1, so I'm going to go ahead and begin by going down 1. And my slope is negative, so it's going to go downhill this time, again, just like it did in the last one. It's just going to go down 3, right 1, or up 3, left 1. And I could keep going up 3 and left another, or I could just stop there. Either way is fine. Number 3, y equals 2/5 x plus 2. So this is in slope-intercept form because y equals mx plus b. The m here is 2/5, and the b is 2. I'm going to begin with b by going up 2. And then my slope is a positive 2/5, so it's going to go uphill as opposed to downhill like the last two have. I'm going to go up 2 right 5 or down 2 left 5. And we end up getting these values. Number 4 here, this is in slope-intercept form, y equals mx plus b. As I mentioned, this whole page will be in slope-intercept form. So the m is negative 1/4, and the b is 3. So I begin at b by going up 3, and then I go down 1 right 4 to make it go downhill from left to right, or I go up 1 left 4 to make it go downhill from left to right. And then we connect these with a line with arrows at the end and call it good. Number 5, y equals 2x plus 6, so the slope here is 2 or 2/1, and the b is 6. So I'm going to begin by going up 6, and then I'm going to go down and left. Now I can't really go up and right very well without going off the graph, and so I'm just going to continue to go down and left another time, just because I wanted 3 points, even though you technically only need 2. Number 6, y equals negative 3 halves x minus 5, so the slope here is negative 3 halves, and the b is negative 5, the y-intercept, and so I'm going to go down 5 here. And my slope is negative 3 halves, meaning it's going to be negative, so downhill from left to right. So I'm either going to go up 3 and left 2, or I'm going to go down 3 and right 2. Down 3 and right 2 is a little bit difficult here, given the fact that, well, it would run off the graph, excuse me. Number 7, y equals negative 4x. So here the m is negative 4, or negative 4/1, and the b is technically 0. We're adding 0 at the end. That's why it doesn't show up. So I'm going to begin with b, and then I'm going to go down 4 right 1, or up 4 left 1, and we're going to make this go downhill. Now we look at number 8 here, and this is in the opposite order from what it normally is. Normally it's y equals 5x minus 3. Don't let that trick you though. The m is still whatever's multiplying with the x. In this case it's 5/1, a positive 5/1, and the b is negative 3. I do need to note it's a positive 5/1 and the slope ends me. That way I know it's going uphill as opposed to downhill from left to right. Since b is negative 3, that means we are saying that it has a y value or a y-intercept of negative 3, so I go down 3, and that's where it crosses the y-axis. Then I use my slope of 5/1 to either go up 5 and right 1, or down 5 and left 1. And considering I can't really go down and left very well, I'm just going to go up and right. Closing out this page, number 9, once again, they're written in the wrong order, so it'd be y equals negative 6/5 x plus 1. Technically, you don't need to rewrite this in the correct order in order to graph these, unless it's specifically asked to be in slope-intercept form before you graph it. So then I'm going to go in with my b, go up 1, and then with my negative 6/1, I'm going to go down 6, right 5, or up 6, left 5. But I would have a hard time fitting up 6, left 5 on the graph, so I'm just going to not do that one. Moving on to the next page here, we see that on all 8 of these problems, that y is not by itself. It is not in our slope-intercept form. So we first have to work to get it into slope-intercept form. So a reminder that slope-intercept form is y equals mx plus b. Y equals literally everything else. So y has to be isolated. So on number 10, in order to isolate y, we need to say what's happening to y. Well, it's being multiplied by 3 and added by x. We typically undo the addition first. It makes our life easier if we undo the addition first most often. And so we're going to undo the addition by subtracting x. And x minus itself is 0. Anything minus itself is 0. And we're going to get 3y equals negative x minus 3. Now, I can't combine negative 3 and negative x, but I can write it like this. And I could also write it as negative 3 minus x and switch this around. However, I actually do specifically want it in this order so that my mx comes before the b. Now as I divide every single thing by 3, I end up with y equals negative 1/3 x minus 1, And now that it's in slope-intercept form, y equals mx plus b, y equals literally everything else, we can identify our m and b. So the m is negative 1/3, the b is negative 1, and I'm going to b again at b by going down 1, or to the y-intercept of negative 1. And then my slope is negative 1/3, so it's going to go downhill, which is going to look like this, as opposed to uphill, which looks like that. And we're going to go down 1 right 3, or up 1 left 3. And connect them with a straight line. And we end with arrows, and my attempt at an arrow on the left, and then the actual arrow. Then now we're going to look at number 11 here. So to isolate our y, we note that y is being subtracted from x. Now note, the y is being subtracted, the x is not being subtracted. So in order to get rid of the x, move the x to the other side, we do not add x. Because if we add x with x, we get 2x, and that does not help us. We need to then subtract x regardless of the fact that this is negative. And x minus itself is 0, and we still have this sign with the y, so it's a negative y equals negative x minus 5. Now we divide everything by negative 1, because y still isn't quite isolated, secretly a negative 1 times y. And I get y equals x plus 5. And now we got this in slope-intercept form, so I identify m as 1/1, b as 5, and I b again at b by going up 5. A positive slope, so it's going uphill, and I go up 1 right 1, or down 1 left 1. Moving on to number 12 here. Try to get y by itself, we have to move this 5x first, and I will subtract 5x because it is positive 5x. Once again, this does not tell us how we get rid of the x. So we subtract 5x and we get negative y equals negative 5x minus 3. Now I'm going to go divide everything by negative 1 just like I did last time, and I get y equals 5x plus 3. Identifying m and b, I get m is 5, or 5/1. The b is 3, so I begin with b by going up 3, and then I go up 5 right 1, or down 5 left 1, and make my ordered pairs, or my line with arrows there. Moving on to number 13. In order to get rid of this, or get this y by itself, we have to undo the 4x and the 3. The 4x is adding / subtracting. In this case, just adding, so we subtract it, and we do that one first. Do that once on both sides. I can write that right one a little bit better to clarify it is on that right-hand side. And 4x minus itself is 0. I get 3y equals negative 4x plus 21. The 4x is negative, the 21 is positive, being careful to make sure the signs are with the appropriate terms. Now if I divide everything by 3, I get y equals negative 4/3 x plus 7. This doesn't reduce, and that's okay. We're going to go ahead and identify that as our m, negative 4/3. Where the negative is on that fraction doesn't even matter a little bit, because regardless, the fraction is negative, thus the slope is negative and going to go downhill. So we begin at b by going up 7, and I'm going to go down 4, right 3. And I can't really go up 4 left 3 very well, but I can go down 4 right 3 again, I suppose, if I want to do 3 points. Truly a minimum of 2 are required, but I like going 1 in each direction typically. When I can't, I have to make a third in the same direction as the first. Number 14. We have 2x minus 4y equals 20. There we go. And so I'm going to get rid of the 2x first by subtracting it. We subtract it because a positive 2x minus 2x is 0, which achieves our goal of moving the x away from the side. And I get negative 4y equals negative 2x plus 20. Divide every single thing by negative 4. And I get y equals positive 1/2 x minus 5. So I identify my m, or my slope, as 1/2, my b as negative 5, and I begin by going down 5. And then in a positive manner, going uphill from left to right, I will go up 1 right 2, or down 1 left 2. Now I got number 15. So 2x plus 3y equals 0. Don't panic because there's a 0 here. We're going to treat it like we would any other problem. So we start by subtracting 2x. And I get 3y equals negative 2x. And I could write plus 0 if I really want, but it's unnecessary. So I divide everything by 3, and I get y equals negative 2/3 x. Once again, I could technically write 0. 0 divided by 3 would have just been 0. But regardless, I note that my m is negative 2/3, my slope. Once again, where the negative is doesn't matter even a little. And the b is 0, since we're not adding or subtracting anything. And so I begin at 0, b, the origin, and I go down to right 3, or I can go up to left 3 to go downhill with a slope of 2/3, aka negative 2/3. Number 16. So I have to get rid of 10x, but to do that I subtract 10x. I get negative 8y equals negative 10x plus 24. I now will divide every single thing by negative 8. I get y equals 5 over 4x minus 3. I can note that my m is 5/4. My b is negative 3. So I begin at negative 3, and I go up 5, right 4, in a manner that is uphill from left to right. Oop, I went up 5, right 2. That's up 5, right 4. Or I can go down 5, left 4, once again, in a manner that is uphill from left to right. On number 17, this is not the problem, but I do want to note, if this was a negative 9x ever, if that x term is ever negative, we would add to get rid of it. It wasn't shown in today's notes, so I want to make sure that I talk about that. That if this x term were ever to be negative, you would get rid of that by adding, regardless of what the sign is here. So we would just add 9x to both sides, because negative 9x plus 9x would get you 0. Now, on how the problem is actually going to be done, since it is a positive 9x, we will subtract 9x from both sides. This gives me 12y equals negative 9x plus 12. Dividing both sides by 12, I get y equals negative 3/4 as it reduces x plus 1. Note that my m, or my slope, is negative 3/4. Once again, that where the negative is negligible, aka doesn't matter. The b is 1. And so we begin at b by going up 1, and I go down 3, right 4, or I can go up 3, left 4. Make my line, connect the arrows, and there it is. And that wraps up section 5.2.